Hello everyone and welcome to Steam Game Analysis presentation today. Steam's popularity and extensive user reviews offer insights into the gaming industry. Our analysis aims to offer companies insight that can improve game quality, fine-tune marketing and investment decisions, and empower gamers with the knowledge to make better choices. We analyzed the three cargo datasets, Steam's 21 million reviews for 300 games in 2021, raw attacks for over 40,000 games, and sentiment score for the top 10 games. We utilize a suite of tools tailored to each stage, from Cargo for data sourcing to Python-based ETL processes with Spark, Parquet, and PyIRO. Our analysis stage hinges on Pandas, PySpark, and Matplotlib. For storage, Cassandra and Amazon S3 provide reliability and scalability. Machine learning insights are powered by Amazon SageMaker, PyTorch, sklearn, and Hugging Face, culminating in a web app through React and Flask. The first question is the frequency of popular words that appeared in positive reviews. Players often highlight friends, playing, love, and recommend among their top positive sentiments. These terms reflect a strong community aspect, with friends and playing suggesting a social and engaging gaming experience. The second word cloud image also reviews some other interesting words, such as 10 of 10 and amazing. These standout words correspond with high frequency and positive sentiment of the reviews. To gauge how games rank in reviews and recommendations, we first aggregated reviews by game names, quantifying the positive and negative sentiments using a Spark data frame. After joining this with Alex dataset, we got the recommendation ratio for each game, providing a robust measure of their popularity. With Matplotlib, we visualized our findings. Games with more positive reviews typically have higher recommendation rates. Team Fortress 2 holds a top rank, while PUBG ranks the lowest. Despite fluctuations, a downward trend in recommendations is evident. This correlation appears logical, as games receiving more popularity are more likely to be recommended.
The next question we are interested in is whether there are some similarities in game genres that player plays. So we grouped by each player, one-hot encoded the game genres that they play, and printed out a similarity heat map matrix graph. This graph indicates if a player plays genre A, how likely it is they play genre B, which can be an important information for game companies to know what genres of games they should expand upon with the current games they have. Specifically, we can see that there are a few genres that are closely related, such as single-player and story-rich, multiplayer and VR, as well as indie and 2D games. We can then rearrange the columns and rows to form a cluster heat map, where the closer the genres are indicates the more similar they are. Note that there is a direction where if player plays genre A, what is the chance they play genre B? Given the direction, we can quickly see that there are a few genres in genre B grouped together with high probability in the whole column, which are indicated in darker red. This signifies that these genres are commonly played no matter what other games the player plays. For example, single player, action, multiplayer, and atmospheric. With the same logic, these are some of the genres that are not correlated with many other games, possibly because they have its own target audience of players, notably genres like puzzle, VR, and violin. Finally, we can see some small groups formed, like the one in bottom left, grouping those exploration games together, for example, story-rich, fantasy, and RPG. As there is a clear similarities in certain genres, we immediately thought of the possibilities of grouping certain genres together. As we already have a similarity matrix between genres, we can use the agglomerative clustering algorithm to divide genres into groups. It is an algorithm that recursively merged the most similar genres together given their similarities. After testing different groupings, a clustering of 8 groups gives the best result. We can see some clear trend like casual simple games in group 0, exploration games in group 1, and difficult strategy games in group 2. Given such genre groups, we are curious whether we can define some common player types in each genre group. We defined player type by 3 characteristics: average playtime, number of games owned, and amount of money spent. In the first step, to find the player trend, we find the average of the 3 characteristics from the histogram, where the average are playtime of 143.9 hours, 91 games owned, and $8.79 spent overall. In the next step, based on the genre groups we obtained, we find and aggregate the average of the game time, money spent, and games owned for each player in the genre group. And finally, in step 3, we use the average we found in step 1 as a benchmark to divide the player type. We can then see a clear pattern where genre group 1 to 4 have dedicated players that are more willing to spend money. We found this unsurprising as genres like fantasy, adventure, and VR often require players to play more to discover more of the games.
In this slide, we'll explore whether specific game genres receive more favorable reviews. First, let's look at the left plot, which displays the genres that rank in the bottom 20 in terms of positive reviews. The first group we can observe is multiplayer games such as MMORPG, MOBA, and massively multiplayer. These games tend to receive fewer positive reviews, possibly due to server issues, connectivity problems, and higher exposure to negative interactions and toxicity. Also, we can find a group of sports games, for example bikes, pool, and basketball, where the lower proportion of positive reviews might be attributed to potential lack of realism. Players may find these sports simulations do not fully capture the realistic elements. Finally, as for gambling games, potential factors include issues with fairness and transparency, as well as the low chances of winning, which may lead to financial losses. Now, let's look at the genre that rank among the top 20 in terms of positive reviews, as shown in the second plot. Drama, romance, documentary, emotional, cat, and cute have higher positive reviews, possibly because these genres connect with users emotionally and evoke relaxation and positive emotions. Niche genres like programming, word count, and puzzles attract a specific and dedicated audience with particular interests, leading to higher positive reviews. To answer the question about the most endorsed genres, we examined the plot, revealing a clear decreasing trend in the total recommendation scores as the genre's popularity decreases. This implies a positive correlation, suggesting that genres that are more commonly found in games are more likely to receive recommendations from players.
Besides data analysis, we incorporated 3 machine learning models to expand the project scope. Considering the scalability, we adopted the Albert model for sentiment analysis, a light version of the BERT, optimized for large dataset through parameter reduction, ensuring efficiency without compromising performance. In training Albert model, we used an 80-20 dataset split. This graph illustrates the downward training loss, stabilizing around 0.216 after 5 epochs, suggesting a fine balance between accuracy and generalizability. We achieved a remarkable F1 score of 0.9421 on our testing set, indicating high precision and recall. The confusion matrices here, validation on the left and testing on the right, and you can see that most predictions concentrated along the diagonal, which shows high robustness and is critical in real-world applications. To ensure our model scales with the growing data, we also leverages AWS SageMaker, a robust environment ideal for efficiently training machine learning models at scale. With data and model stored in S3 buckets and fetching data through S3 URLs in SageMaker Studio, it guarantees efficiency, regardless of data size increases, ensuring swift data handling for continued model refinement.
We developed 2 recommendation systems that suggest similar games. Both models employ cosine similarity metric. However, to find similarity between games, the content-based model transforms the game's content features into numeric representations that capture frequency and importance of words, whereas the item-based model analyzes a user's historical playtime data and suggests games with the most similar playtime patterns.
We have created a full-stack website to provide interactions with our 3 machine learning models. We first store all the reviews and sentiments in Cassandra, then pass the data into backend Flask and Python. Finally, develop the UI with React.js. Here is a demo of our web application. So here is our website. Each game will have their own dedicated page to view the analysis. For example, let's see the Civilization 6 game. In this application, there are 2 tabs. The first tab displays all the English reviews stored in the Cassandra database for Civilization 6, also showing the sentiment analyzed from the sentiment models that we have trained. In addition, we have extracted some common keywords in the reviews for this game and displayed on the top. In the second tab, it performs recommendation given certain games based on the 2 recommender model we trained. For example, for Civilization 6, here are the recommendations. We can see that there are some games that are recommended by both models. For example, Civilization 5, Total Warhammer, Stellaris. And here are some other examples. Thanks for listening.